Yeah, just a few minutes, I'll start. The online training at the rate nareshit.com. At the rate nareshit.com. Send an email to them. Okay. So now yesterday where we were? Yesterday where were we? Yeah, Google Classroom link. Yeah, I did not get that link. Okay, I think tomorrow I'll get that link and share to all of you. Okay, then. All right, I'm sharing my screen. Okay. I'm sharing my screen. Okay, can you see my screen, everyone? So yesterday where we were? Yesterday I have written the source code for adding or registering the customers for a customer relationship, and we did not use any database. I used an in-memory data store, which is called hash map or collection. Java, it is a part of Java collection. Okay. Now we will write the test case. Okay, for test case, what we have to do? Go to your test Java. Okay. Just refactor, rename customer manager test. Customer manager test. Okay, I think this is all JUnit 3 related packages. So remove all this. We have to use JUnit 5. Remove all this because Maven has generated JUnit 3. So we have to use JUnit 5 related. Okay. This is the test class. Just like how we have written this test class for a simple addition and in the earlier example. Now we will write the test class to test the customer manager. Okay. First, see what I'll do is I'll tell you some more unit testing related features. Okay, for example, in last example, we have seen very simple asset equals, asset not null, those things, right? And what is this? This is a test method. Now we will actually see some more scenarios. As I told you, we have a test class. We have a test class. The test class contains test methods. So when you say test methods, the methods annotated with @test, right? So in a test class, I can have in a class, I can have multiple test methods. Say, let us take this is some test class. Okay, let us take this one. So I can have multiple test methods. Test. method 1, then next test method 2. Like this, I can have multiple test methods, right? And each test method will have multiple test cases. Inside this test method, we can write multiple test cases. Like yesterday I was telling, like in this test method for adding, we are checking if expected output is equal to actual output. We are checking if actual output is not null. These are multiple test cases. Now, in addition to that, we can also have, suppose if you have test class like this, so method 1, sorry, test. So method 1, okay, method 2, something. What this does, in each test method, we'll be testing the respective business methods in your class, in your business class. I can also write one more scenario is like before all. Okay. And before each. Okay, what this does actually. So these are your test methods. Okay. And for example, let me write one method here. On this method, I'm writing one annotation. Public void sum init. I'm just writing one. Similarly, I'll write one more annotation before each. Okay, public void, say init1. I'll write like this. So the methods annotated with @test, annotated with @test. Okay, the methods annotated with @test will be executed as part of testing. Who executes this? Who executes this test method? Who executes this test method? When we run this program, as a JUnit test, run as JUnit test, run as JUnit test. Okay, the test methods get executed one by one. Gets executed one by one by JUnit framework. So when we run this as a JUnit test, one by one. So first this method gets executed. Next this method gets executed. Suppose in this method, if any of the test case fails, so then this will throw error. In this method, if any of the test case fails, this will throw error like that. Then what are these methods? The methods with before all, before each. Okay. So when we take the life cycle of a test method, first will be @before all. Okay. Next will be @before each. Next will be @test. What do you mean by this? I'll tell you. And why we need also I'll tell you. So what do you mean by this is I'll tell you this. So when I execute this test class, when I execute this test class as a when this test class is executed as JUnit, okay, as a JUnit class. So first it will check if there is any method annotated with @ before all. So first it will check in this class if there is any method, that is annotated with @ before all. Yes, there is a method, this method. So first it will execute this method. So first it will check if there is any method annotated with @ all. If that exists, if that method exists, then if that method exists, then it will execute that method first. Then JUnit framework will execute that method. Okay. Then, okay. Now you see. Then JUnit will check if there is any method with @ before each, annotated with @ before each. Okay. Then if that method exists, it will execute that method. Next JUnit will execute @ test method. Okay. Next JUnit will execute @ test method. Now, after JUnit executes test method, executes @ test method, it will see if there is another @ test method. So if it exists, then before executing @ test method, it will execute @ before each. I'll tell you with an example, you'll understand clearly. Now you see, let me write one test class here. Very simple test class. Okay. Class X. Okay, let us think like this. This is a test class. Or we can think this X test. Now I'll say @ before each, before all. Then I'll say method 1. Okay. Then I'll say @ before each. Then I'll say method 2. Let us think like this. Next, I'll have one test method, method 3. Next, another test method, method 4. Next, another. Okay, that's up. We'll have the simple test class. Now when JUnit executes X test, when JUnit executes X test class, so first it will call method 1. Next, so it will call in this order. First method 1, second method 2, next method 3. Okay. Now you see fourth. Now it will see there is another test method, but before executing this test method, again it will execute method 2. Again it will execute method 2. Method 2. Okay. Then method 4. So what you mean by this is the order. Method 1 means before all. Before all these test methods, first before all gets executed. And before each gets executed, before executing every test method. That is what the difference. So before all will get executed. Before all will get executed. Will get executed. Before executing all test methods. Okay. So before each gets executed, so this gets executed. Before every test method, before executing every test method. Okay. So you see here. So you can change the order also, not an issue. But before all will get executed before executing all test methods. And before each gets executed, before executing every test method. Every test method. So if you see the order now, how many test methods are there? These two are test methods. Before executing any of these test methods, first before all gets executed. That means method 1 gets executed. Next, before executing method 3, before each means method 2 gets executed. Next, method 3 gets executed. Then before executing method 4, again method 2 gets executed. Then method 4 gets executed. Just 1 minute. Sorry, I got a call. Another. So before all will get executed only one time. Remember, before all will be getting executed. One time in the entire test class. in the entire test class execution. Okay. Now, before each gets executed, every time before @test method gets executed. Before every @test method gets executed. Now you see, now if you see before all in this program, before all gets executed how many times? Only one time. Before each gets executed how many times? Before every test method. How many test methods are there? 2 are there. So before executing this method, this gets executed. Before executing this method, this gets executed. So how many are there total? 2 times. So before each gets executed 2 times, this time and this time. Okay. Now you see, we'll write one more program so that you will be clear. Now we'll say class y test. Now I'll say @. Now I'll reverse the order, okay, before each, okay, just for, I'll say method 1. Next I'll say before all method 2. Next I'll say test method 4, method 3. Next I'll say test method 4. Next I'll say test method 5. Like this I have. Now, suppose now, how many times, now what is the order now? Tell me the order. First before executing any of these test methods. First before all gets executed. That means first method 2 gets executed. Next. Now, how many test methods are there? 3. Now, before executing each test method, before each gets executed, that means method 1. Next, it will execute the test method, which is method 3. Next, before executing again method 4, before executing this test method, again before each gets executed, that means method 1. Next, after executing method 1, it will execute the test method, right? Method 4, right? That means this one. Next, before executing this method 5, it will execute again method 2. Method 2. So again, after executing before all method, sorry, not method, right? Method 1, sorry, method 1. This one, right? Method 1. This one, right? This one. Method 1. Next is 7. Next method 5. So first before all gets executed, that means this one. Next, before executing this test method, it will execute method 1. That is before each. Next, it will execute method 3. Yes. Next, method 1 means again before each, again that gets executed. That means why it is executing? Because before executing method 4, it has to execute this method. So first method 1 gets executed, next method 4. Next, before executing method 5, it will execute method 1. Next, method 5. So if you see, before executing every test method, first this gets executed, method 1. So this is the order. Everyone clear with this order? Any doubts? Everyone clear, right? Now, then why we need this before each, before all? What is the purpose actually? Okay, I'll tell you. So I'll tell you this. Now our actual methods in any test class are methods that are annotated with @test. These are the actual test class methods. Now, if all these test methods are using a global variable or a common variable, if all these test methods are using a global variable or a common variable that needs to be initialized, we can set that in the method which is annotated with @before all. We can set that with the @before all. Okay, I'll tell you one simple in this example. That means before all will be executed. This method will be executed before executing any of these test methods, right? So before executing all this, and it will be executed only once. And whatever the variable that I initialize here can be used across all these sections. Okay, I'll tell you how. So now let us see this. Just one more. So what I'll do is, here I will write @before all, and here I'll say public void initialize common data. I will write a method like this. Okay. So here what I'll do is, now if you see this test class we are writing for an organization, right? We are writing for this an organization, Airtel organization. We are writing this test class for an organization, Airtel. That means organization is common, a global data that can be used in this test class. So what I'll do is here, I will create an organization like this. Private. Okay. And here I'll put a static. Okay, this can be static because it is a global. We can initialize the static will be initialized only one time actually. So I'll say private static string expected organization. Let me do this. Organization is equal to like this. And here I'll say, okay, let me add in the pom.xml this dependency. Okay. So before all, I'll use, and this is a part of your JUnit package, JUnit package. So here I'll say expected organization is equal to Airtel. Okay, I can initialize a common global variable. Okay, here I'm initializing a global variable that can be used in any test method. Okay, I'll do like this. Now, what I'll do is I'll just write one test method for now. Simple test method. Okay. Okay, I'll write only one before all and test method. Okay, before each we'll see afterwards. Okay, we'll see afterwards. First, I'll write with before all and test method. Only one test method and before all. If I have only one test method, before each is not required. Okay, before each is when it is required. When before each has to be executed before every test method. Suppose if I have 3 test methods, before executing first test method, before each has to be executed. Before executing second test method, before executing third test method, before each has to be executed, like that. But now I have only one test method and before all. Okay. Now here what I'll do is public void. I'll just say like this: add customer test. That is the business logic right here. Adding customer. So we have to test this method actually. So for that I'll say add customer test. Now here what I'll do is immediately first test case I'll say asset. Okay, let me do like this. Let me do like this. I will create a customer manager. Or I'll do like this one. First test case. Check if expected organization name is matching with actual organization. So this is the first test case. Check if expected organization is matching with actual organization. So how I'll get actual organization name? I'll get this from customer manager object, right? I'll get this from customer manager. If I create customer manager object and get organization name, I'll get the organization as Airtel. Okay, let me call this. So let me create an object customer manager is equal to new customer manager. Then what I'll say manager dot, okay, get organization. Okay, so I'll say string actual. This is our actual organization name, right? Organization. So this is your actual object. From the actual object, I'm calling get organization, which I'm getting, and I'm defining here expected organization. So I can now do that asset equals expected organization, comma, actual organization. Okay. Any doubts still now here? Right. Okay. Basically, here you don't need object also, right? Why? Because it's a static method. This is a static method, right? This is a static method. You can directly call from the class itself. Okay. Now you see customer manager dot get organization name, because this is a static method. This is a static method. Directly I can call static method from class name only, right? Why to create object? That's what. Okay. Now you see. Now just I'll run this. So I'll put just system dot. I'll just put system dot out dot println in before all. Next in @test. Okay. So if you see the order, run the order. Right click on this, run as JUnit test. Why it is not coming? Why it is not coming? If I run this, I'm getting JUnit test. But if I run this, why I'm not getting JUnit test here? Okay, because it is in 1.5 version. I have to change this properties, Java build path. I have to remove this 1.5 version, add library, JRE system, JDK 17, Java compiler, 17 version. Apply. Yes, apply and close. Okay, fine. Now if I run as JUnit test, I'm going to see here. So now run this JUnit test. Now see, first what has printed? This has printed. First this method gets executed, which is with @before all. So first this is printing, then it is initializing this variable, then it is coming to the @test method, which is this is printing, and then here I am just telling asset equals of expected organization, this one. Now we'll see whether this test case passed. Yes, this is green color. It is, yes, it is passed. Suppose here I give instead of Airtel, I'll say Geo. Now let me run this, run as JUnit test. Now I see before all, but JUnit got failed, you see. Because the actual is Airtel, but expected is Geo. That's why you are seeing failure. Okay. So now this is the first test case. Now we'll see the second test case. Second test case, what we do is, so we will just test for this method, test for the add customer. Okay, add customer. So what I do is here, I create, okay, here first define. If you see in our test case methods, what are the steps we have to follow? Define input to be passed, right? That is the first step. Next, define the expected output, right? This is the standard way. Next, call the actual method and get actual output. Next, compare expected output, and actual output, right? That's what we have to do, right? Now, first define input to be passed. Now, if you see in this method, add customer, what is the input we have to pass? This is the input we have to pass, right? So let us define those input. First, define input to be passed. String. Okay, what are the inputs? Customer ID, first name, last name, phone number. So string customer ID is equal to C100. I'm giving some dummy name. String customer name, not customer name, right? No, first name, last name, and phone number. String first name, Ravi Babu. String last name, Babu. String phone number. Okay, some number. Okay. This is the input. Okay. Now, what we are going to test now? What is the second test case? If you see the actual test case, when we pass one record, first we have to define when we pass one record to add customer method. Okay. And then call get all customers method, and then call get all customers method. The output should be then call get all customers method list size. The output should be 1. This is the test case. That means you see here, you understand here. When I call add customer method by passing this input, okay, after calling this, immediately I will call this method. Immediately I will call this method. It will return a collection there. And what will be the size? It will be 1. It will be 1, right? Right. That is the logic, right? Here, you see here. This is the second test case we are testing. So first we call this method. When we call this method, pass some input here. Okay. After calling this method, what it does, it is adding some record in this collection. Now after calling this method, then we call this method. First call add customer method. Okay. Second call get the call customers method and get the list size. Can anyone tell what will be the list size? Call add customer method passing the input. Can anyone tell if I call add customer method by passing the input, next call customer method get the list size. What will be the list size? It will be 1. Why? Because I call add customer, this logic gets executed. In this one record gets inserted. Now immediately I'm calling this get all customers. It is returning the hash map value. See, when I call this method, it will create a hash in the hash map. It will insert a record. This record will be inserted here. Okay. Now, when I get all customers means I'm returning the values from this hash map. How many records size will be there? It will be only 1 record. It will be 1 record, right? It will be 1 record. So that is the test method we are doing here. That is the test method we are doing here. Okay, that is a test case. That is a test case we are doing here. Now, what is the expected output? I am testing for the record size. Int expected record size or record count. is equal to 1. Now call the actual method to get the actual output. Now to call the actual method, we have to create the customer manager object is equal to new customer manager. Next, manager dot get customer data dot size. So this will be your actual record count. Okay, before that, I have to call this, right? Manager dot add customer. I have to pass on this. Now compare the expected output and actual output. So what I'll do here, assert equals of expected record count, comma, actual record. So this is what we are doing. This is the second test case. So what we are doing, we are adding customer data, and then if you are actually getting the size of that customer record, you should get 1. Expected record count is 1. We have to get the actual record count also. So that is what we are doing here. Now this test case will be passed or failed. This test case will be passed or failed. It will be passed, right? It will be passed. So run as JUnit test. Geo Airtel. Okay, here I have to change it. Airtel, this can't fail because here it is failing actually. So if it is failing here, it will not go to the second test case. So run as JUnit test. Now you see this is passed, green color. Let us make this as third test case. Okay, now let us make this as third test case. Before this, we'll have one more test case. This is third test case. Now, before this, we'll have one more test case. We will check if the returned collection is empty or not. Is empty or. So here what we do is, here we got manager.get customer data. Let me take this as collection customer. This is collection, I'll say. And this will be get customer data. No, this is, sorry. What is this? So this is get all customers. This is get all customers. Sorry. Okay. Now here I'll say in second test case, assert false. Assert false. I'll say here customers. Customers dot is empty. I'll say like this. So what do you mean by this? Assert false means Accept false means, suppose if customer is empty is false. Just read the trick here. If you see here, what accept false will tell is the, let me do like this. Okay. When I say accept false means the expected output is to be false. Okay. If actual output is also false, then accept false will pass the test. Now you see what I'm doing here. You see, I'm adding a customer here. Just to see, just watch carefully. What I'm doing here, first I'm adding the customer. Next one, once customer is added, get all customers. What do you mean by get all customer? It returns a collection. It returns a collection, right? It returns a collection. See, when I say add customer means this logic gets executed. This logic gets executed. Okay. This logic gets executed. Now, when this logic gets executed, it will be stored in the customer data. What is your customer data? Your collection. Now, when I say get all customers, what is the logic it gets executed? This logic. This logic. So what it is returning? It is returning a collection. It is returning a collection. It is returning a collection. Okay. Now you see. Now when I say accept false, what do you mean by accept false? Means the expected output is to be false because we are judging it as a false. If the actual output is also false, then accept false will pass the test case. Now you see, what is the actual output? This is your actual output. Customers dot is empty. What is your customers? It's a collection. Is collection empty? Is collection empty? No, it is false. Why? Because this collection contains one record. Because I added this customer record, right? This record is stored in the collection, in the hash map. Now, when I check whether this collection is empty, no, it is a false. So it means the actual output is false. So expected output also is false. So your accept false will pass the test. Okay. Now we'll see one more for your understanding. I'll just tell you accept true, not here. We'll take this as the fourth test case, third test case, and the next one is fourth. I'll say accept true. What do you mean by accept true means? What do you mean by accept true means? Accept true. So accept true, what it does is, accept true means the expected output is true. The expected output is true. That means accept means confirm or judge. I mean, it is confirming that expected output is true. Now, if actual output is also true, then test case is passed. Otherwise fail, else fail. Else failed. Now you see, customer start is empty. Is it false or true? It is false. It is false. Because Customers is not empty. So that means your actual output is false. Your actual output is false. Your actual output is false. As your actual output is false, but asset true, what asset true tells? The expected output is true. Asset true tells that the expected output is true. Asset means it will confirm that the expected output is true. Asset means confirm. Now, the expected output is not matching with actual output, so this will throw error. This means this will make fail. Test case fail. Okay, now we'll see one more scenario just for your understanding. I'll say asset true of like this. Now this test case is pass or fail. Now you see what I'm doing now. Here I'm adding this one. Right? So I'm just putting here asset true. Now when I call this code, okay, it will actually create a hash. It will create an entry in the hash map, right? It will create an entry in the hash map. Now, when I say get all customers, it will return this hash. Okay. Now, customers is empty. So what asset true tells? Asset true tells that expected output is true. Output is true. Now, what is your actual output? This is your actual output. So, customers dot is empty. Customers dot is empty is false. So when I say not customers dot is empty, that is true, right? That means your actual output is true. Now your expected output is true, your actual output is true. So thereby this test case is passed. Because here we are using not actually, not operator. When I say not, that means it is true. Because customers dot is empty is false. So when I say not, this is true. That means your actual output is true. Your expected output is also true. Now I'll ask you one more question. Is it false or this one? So what is your expected output? When I say asset to false means you're confirming it, the expected output is false. That means the expected output is false. Is false. Now, whenever I say customers means this record has been added. So this is your actual output. So customers dot is empty is false. Is empty is false. No, not customers is empty is true. That means actual output is true. Okay. Expected output is false. Actual output is true. So this test case fails. Everyone understood till now? Okay. So what we'll do is, everyone clear? See, asset means you have to think like, whenever I say asset means the expected output, asset means the expected output is true. Similarly, in the case of asset equals also, you can think like that. Asset equals also. Okay. Expected output. Actual output. So if you think like this, asset means what? That means the expected output should be equal to the actual output. Asset means confirm on the expected output side. Asset means it is on the expected output side. So the expected output should be equal to the actual output. When I say asset true means the expected output should be true. When I say asset false means the expected output should be false. Okay, like that. In yesterday's example, we have seen some asset not null. Okay. So when I say asset not null means the expected output should be not null. When your actual output is also not null, then test case is passed. If your actual output is null, it is failed. So when I say asset not null means expected output should be not null. Is not null. If actual output is also not null, then test case is passed. So now we have to think like assertions is like that. Asset means confirm on the expected output side. Okay, then tomorrow we'll meet. Tomorrow we'll complete this program. Okay, tomorrow we'll complete this program. Okay, we'll complete this program tomorrow. Any questions till now? Clear, everyone? All right. You can send an email to this team. Like this, online training. Okay. See you tomorrow. How many of you are clear with this assets? With these assets, everyone clear, right? Okay. Okay, then see you tomorrow. Okay, then thank you all. See you tomorrow.